Hi, how you doing? Welcome to video number 200. So I haven't got anything particularly special planned, but I just thought I'd mention it. This is 200 video, bit of a milestone, okay? I'm going to talk about laws of logarithms. I said I'll do that at the end of the last video. Not only did I have a cup of tea, I'll go change of shirt, shower, shave, everything, okay? It's actually the next day, okay? But it might be in the next minute for you. Anyway, I'm going to talk about the laws of logarithms. And I've just listed them, here they are. Now if you want to get a screenshot of that, here you go. Because I've included a nice picture of John Napier himself, the one who was credited with invented logarithms, of course. And I'm going to talk you through these laws of logarithms, give you some examples of how they work. Okay, just notice this one. It's called the change of base rule. It's a particularly special rule which I'll come to towards the end. So let's look at the first two first of all. So we've got log of xy is equal to log of x plus log y. Now, these work with any base, however, the bases have got to be the same throughout. So if that is, for example, base 7, it's got to be base 7 there and base 7 there. All right? If that's base 3 there, but it will not work if that was base 3 and that was, for example, base 3 and base 2. You've got to have the same bases throughout. And that's the same with all of the laws of logarithms, okay? So the way this works is that you can rewrite, you can split up a logarithmic term. If you find an expression for what this can be split up into in terms of its factors. All right, now here's an example numerically. 15 can be rewritten as 5 multiplied by 3. So you can rewrite log 15 as log 3 plus log 5, as long as it's the same base, of course. Going the other way round, you can see that this expression on the left can be simplified. Okay, now you've got to be able to use these rules from left to right and right to left. That is, you've got to be able to spot when you can rewrite log 15 as two separate logarithms, and you've got to be able to spot when you can combine two separate logarithms into a single one. Okay, because sometimes it's going to better fit our purpose when we're solving equations. So log of 2 plus log of 7 is the same as log 20, all of base 7, of course. Now, as you can imagine, it works the other way round when it comes to a division question, when you've got log of a fractional amount. Okay, so log of x over y is equal to log x subtract log y. So a numerical example here, if you've got log of 2/3, that could be rewritten as log 2 subtract log 3. Going the other way, if you've got an expression that says log 4 subtract log 5, that can be written as log 4 over 5, log 4/5. Okay, so you've got to be able to go both ways. Sometimes I call this the multiplication law, sometimes I call that the division law. Now, before I go ahead and talk about the next logarithm rules, let's just take a moment to see how that relates to exponentials, shall we? So what I'm going to do is I'm just going to get rid of all of that. In terms of exponentials, if you have 10 to the power of 2 multiplied by 10 to the power of 3, what would you do? You'd add the powers together. You'd have 10 to the power of 2 plus 3, which is 5. Another example, if you had 7 to the power of 6 divided by 7 to the power of 4, what would you do? You'd subtract. Okay, you do 7 to the power of 6 subtract 4. Okay, so these logarithm rules, they are intuitive once you get used to them because they're basically following the same pattern as the laws of indices. And there's no surprise there, I hope, because logarithms are the inverse of indices. So that's why the rules are coming across as very, very similar. Let's have a look at the next couple, shall we? So this one here, I call the power rule, and it's about using the power of this logarithm here. So you've got log of x to the power of n. You can rewrite it as n log of x. Obviously, same base again. So what does that mean? Let's just put it back into this mode. So what does that mean? In terms of this expression here, you can rewrite log x squared, you see, as 2 log x. And they might think, well, so what? Well, if I just go back to this rule here, okay, now, this rule can only be applied if you've got the same coefficient of the log terms. So, where do I have it? This one here, if I change this question slightly to that, log 7 plus 2 log 10, you can't apply this rule anymore, okay? The rule will only work if you've got the same coefficients there, there, and there. So, for example, this would work if I had 3 of that, is 3 of this plus 3 of that. That's absolutely fine, but it's not going to work if I have 2 different coefficients. So what would I do? In this instance, I would use the power rule. Okay, I would use the power rule. So I'd keep that as the same, log of base 7 of 2. And what I'd do is I'd put that 2 as a power. I'd write it as log base 7 of 10 to the power of 2, 10 squared. Okay, so the power rule comes in really, really handy because you often need to use it when you want to make use of these. Same with this. This will only work if you've got the same coefficient of each logarithm term, okay? If I had a 7 there, it's not the same thing. It's not going to work, okay? I'd have to have 7 in all places. And just to finish off this then, so that is 100. So I'd have 2 there, 100 there, and then I'd use the multiplication rule, 2 times 100, it would be log base 7 of 200, okay? So this is actually an incredibly important and useful rule. Another example of it here, can you see what's going on here? So half of log base 2 of x, you can rewrite that again using the power rule, but the other way around this time. You can put the coefficient there as a power, and that's x to the power of a half. And of course, x to the power of half is root x. Okay, so look out for that one. Going the other way, of course, you need to be able to rewrite log base 2 of root x as a half of log base 2 of x. So that's the power rule. Now, those are the first 3 rules of logarithms. I would say those are the most important, the ones you really, really want to remember, because whenever you're solving a logarithmic equation, chances are at least 2 of those 3 rules are going to come up in the question. Okay, this one here, I'm not sure if it's really a rule of logarithms, but it's worth quoting as a particular result. The idea is that you can rewrite a reciprocal term like this. Log of 1 over x is negative log of x. Do you know why that works? Well, the reason is 1 over x, of course, is the same as x to the power of negative 1. Okay, and what you can then do is bring the power down using, as I mentioned, the important power rule. So you can bring the power down as negative log x. So some examples of where you might see that. So reasonably common fraction like a half or a third or a quarter. Here I've got a half. Log of a half, you can rewrite that as log of, and that's 2 to the power of negative 1 there. And of course you bring the negative down, negative log 2. So really this is kind of an extension of using the power rule. And then there's another example. So negative log base 10 of 7, you can rewrite that as 7 to the power negative 1, using the power rule again. So log base 10 of 1 over 7. Okay. Next, not so much rules, but important results, which I must have mentioned in my previous 2 videos. If you've not seen those 2 videos, watch them, okay, because you might find them interesting. You might gain something a little bit new. In the first one, I'll talk about the graphs of the logarithmic function, and the second one is more of a generalized introduction, what it's all about. This one is all about the rules, of course. I assume you've got some basic knowledge of logarithms already. So here, I've mentioned already, but I'll mention it again, very important result, comes up so often, log base a of a is always 1. That's for when you've got a numerical value of a, just not 0, not 1. Okay, you've got log base 10 of 10. I mean, lots of these things, I'm assuming you know some general knowledge in that we're not using negative bases, we're not using a base of 0, things like that. Okay, log base 10 of 10 is equal to 1. You can check these in your calculator. Okay, you can always just check these, but you think of any base number there that's a positive value, yeah, even fractional values if you want. Log base e of e is 1. Now I've introduced that number possibly for the first time in my videos. It might have come up before because, to be honest, I can't help but mention e. Bearing in mind this is the 200th video I've done, e has got to get mentioned there somewhere, and so has Leonhard Euler, my all-time favourite mathematician. I cannot have a 200th video without at least mentioning Leonhard Euler. Okay, I thought about doing a special Euler video for my 200th, but no, I didn't want to ruin the flow of my log videos. Okay, so maybe another day I'll do something just about Euler. Okay. Anyway, log base e of e is equal to 1. E is an irrational constant, a bit like pi, but even better in my opinion. 2.718281828, and a lot more numbers because it's an irrational constant. Okay. Often we abbreviate that to the natural logarithm, written as ln, but I say the natural logarithm. Okay. And you can write the natural logarithm of e is equal to 1. So if ever you wondered what this button here on your calculator is all about, it's about log base e. Okay, it's a shorthand notation. As I say, it stands for the natural logarithm. And you will have an e function somewhere in your calculator. You'll have a button where you can get e, just as you've got a button that allows you to have pi on your calculator screen, and you can work out natural log of e, and of course it is just 1. Okay, so that's that rule there. This one here, I've mentioned it before, but again worthwhile mention. Log of 1 is always 0. Doesn't matter what base you're actually using here. So for example, log base 7 of 1 is 0. You can check these in your calculator too if you like. Log base 10 of 1 is equal to 0. And of course, using my favourite base of logarithms, natural log of 1 is also 0. Okay, that's probably the quickest one to check in your calculator because there is a dedicated key for the natural logarithm. You can just type it up, natural log 1, and it gives you 0. Okay. Right, next, I'm going to talk about this change of base rule, which is that very, very handy rule. It's handy, most I suppose, if your calculator won't allow you to use different bases. So some of the older calculators only allow you to use base 10 or base E. That being the case, use the change of base rule. Now, I'll give you an example of how it works. Well, just use the right function again. So suppose at some point you need to work out this, the natural log, oh, there I go with the natural, sorry, the logarithm of base 5 of 2. Okay, I just can't help it because it is so natural. Okay, once you start learning about natural logarithms, it suddenly becomes more intuitive. So sorry for the slip of the tongue there. You want to work out log base 5 of 2. Suppose you want to work out what that is. We just use the change of base rule. Now the change of base rule works like this. You can choose any base you want to work with. So you want to rewrite that using a base you'd rather work with. Now for this example, getting choked up must be about the natural logs or even the oil I mentioned earlier. Okay. If you want to change the base, change it to something you want to work with, probably base 10 for your calculator. Now the idea is whatever base you choose, you rewrite it as a fraction, a log term on top, a log term on the bottom, both of them base 10. Okay, so the C there indicates the base that you've changed it to. And then the idea is that you rewrite it as the logarithm of that value divided by the logarithm of that value there. So it reads as log base A of B is log base C of B all over log base C of A. And this numerical example, change it to base 10, you got log base 10 of 2 over log base 10 of 5. The way I remember it is, it kind of looks like it's almost as a fraction anyway, isn't it? 2 over 5. It certainly looks like the 2 is on top of the 5. That's just the way I remember it. Okay, and then you can type that in your calculator and work out the answer. It's quite simple. Give you another example. If you want to work out log base 2 of 3, again using the change of base rule. Now notice this time I've just written as log log, which means that we assume it's base 10. That's the convention. Okay, if you just write log log, you always assume that means base 10. And so that's log base 10 of 3 over log base 10 of 2. And you can just put that in your calculator and it'll do it for you. And lastly, because I really like these, that's what I would do if I had a calculator. Yeah, maybe like a mobile phone. Maybe your mobile phone has got a calculator, but it's limited. Okay, maybe it doesn't allow you to input different log bases. Okay, so that would work. You see, if you've only got your mobile phone, you're going to work out what log base 3 of 7 is. You just change it. I'll change it to natural logs, and I'll write it as natural log 7 over natural log 3. Okay, so there you have it. There you have it. Those are all the logarithm rules again. Maybe later on or in a separate video, I'll give you some further examples of how you actually use them. Okay, I'm hoping you found that useful, and I hope you have a really good day. All right, video 200. Yay, a milestone. So pleased with that. Okay, see you later. Have a good day.